This is going to be another trig subproblem, so we're going to put everything in terms of theta. Now to do that, we need a triangle. How do I know which triangle I'm going to use? Well, remember, trig sub usually has the x squared and an a squared, and it could be minus or it could be plus, but it's always going to be under a root. And in this case, our 4 can be rewritten as 2 squared, so a squared. So this looks to me that we're dealing with an x squared minus a squared type of triangle. So I go to my triangles and I find out which triangle gives me my x squared minus a squared. That's going to be triangle B. So I'm going to go ahead and take this triangle. So then from here, I have to put everything in terms of theta. So I'm going to start with my main thing. I call it my main thing. So find main in terms of theta. So the strategy is every time you want to find something, just put it at the top. So in this case, this is x squared minus a squared. And again, I don't use numbers. I just declare that my a is equal to 2. And then at the bottom, you want to always put your a. And then you ask yourself, blank of theta is going to give me that. So is it going to be cosine of theta, sine of theta, tangent of theta, something else of theta? What is going to give me that? Well, first you have to identify what this is. So I do that by labeling my triangles. So in this case, this is always opposite. This is always hypotenuse, right? And then what's left is adjacent. So this is my opposite. And then my A is my adjacent. So then to figure out what goes here, I like to do SOHCAHTOA. And I ask myself, okay, which one is going to give me opposite over adjacent? Tangent. So the answer here is that tangent of theta is going to give me opposite over adjacent. It's going to give me that. But the goal is I want to get this in terms of theta. So what I can easily do is just multiply by a on both sides. So I can get this by itself. So that becomes a tangent of theta is equal to x squared minus a squared. And that's my first substitution. So given that my a is 2, this becomes 2 tangent of theta, and then we have to put x in terms of theta. So now I'm going to go ahead and find x. So remember, the strategy is always to put what you want at the top, a at the bottom. Ask yourself, blank of theta is going to give me x over a. Well, then you ask yourself, well, what is x over a? Well, the x is going to be your hypotenuse, and your a is going to be adjacent. So then you go to SOHCAHTOA and you ask yourself, which one's going to give you hypotenuse over adjacent? Well, that one's interesting because you see none of them are HA. But remember that there are opposites. Remember, if this is sine, and this is cosine, and this is tangent, remember that their inverses, cosecant, secant, and cotangent, right, are the opposite. So in this case, h over a is going to be secant. So secant of theta is going to give me x over a. But remember, I want x by itself because that's what I want to replace here. So in that case, a secant theta is equal to x. And that's another substitution I can go ahead and make. So given that my a is 2, this is going to become 2 secant of theta. And then finally, I'm going to go and replace dx with a theta. So find dx. Well, dx is really just x prime. So I'm going to take my x, which is a secant of theta, and then I'm going to find x prime. So x prime is going to be a times secant of theta times tangent of theta d theta because I took the derivative. And that's another beautiful substitution that we have here. So it's going to be 2 secant theta tangent theta d theta. Now there are no bounds to put in terms of theta, so we don't have to worry about that. And we ended up putting everything in terms of theta successfully, so we're good. So now we're going to actually do the integral. So in this case, these here cancel out. So we're left with 2 tangent of theta times another tangent of theta. So this really just becomes tangent squared of theta d theta integral here. We can bring out the 2 to the front, and then we have the antiderivative of tangent squared of theta. That is tangent of theta minus theta. And then we bring out the 2 because everything's being multiplied here by 2. And a plus c because it's an indefinite integral. So in this case, this becomes 2 tangent of theta minus 2 theta plus c. And then because it's an indefinite integral, we have to put our answer back in terms of the original variable, which was x, because right now this is our answer, but it's in terms of theta. So we don't want to leave it in terms of theta. We actually want to get the real answer. So we actually have to find what theta is. So I always use this equation where I solve for x to solve for theta. So I take this equation, divide by a on both sides. To solve for theta, I just take theta is equal to the inverse of that, so arcsecant x over a, but a is 2. So then I go ahead and substitute that into here. So this becomes 2 arcsecant of x divided by 2 plus c. Now here's like the interesting part that you want to keep in mind. When you just have theta, you want to find theta. But if you ever have like trig function of theta, you can totally find that using your triangle. So in this case, tangent of theta is what? Well, we already actually did that. Tangent of theta is this. In this case, we have 2 times tangent of theta, which is this. Given that a is equal to 2, these cancel out. Again, given that a is equal to 2, and that, ladies and gentlemen, is our final answer in terms of our original variable x, and we use trig sub to help us make this integral easier to integrate. So I'll see you in the next video.